hello everyone, and we are finishing the chapter on instruction set addressing modes. We have seen many of the addressing modes before. Let me slide show, so this will have more space on the screen, but then I have to do escape. No, let's keep it like this. Let's keep it like this. Okay, guys, this we have went through. Who's gonna answer this question for me, please? Large address space 2 to the power n. Look at this. We have talked about it. طبعا the recording was not available to review, but maybe some of you caught the idea when we were explaining it, because it's a simple idea. So if we were in person, you wouldn't have needed the recording, and you should have went to the notes and figure out everything about any of the addressing mode. Indirect register, indirect addressing. We said that. We talked about it, right, guys? Well, I think yes. The content of the register is the effective address. Let me start annotating. I'll start from here, guys. So this is we're gonna see it in the second. Why should I do this if I see it here? So this is the case. So this is the opcode. This is the register address, and actually it's a pointer to a register content, and that content will take me to the operand in the RAM. It was included in that numerical example that I wrote a program and then we jumped here and there. So you have to review the recording to understand fully what I'm saying. I'm interested in one simple idea here. How many bits are needed in this operand, ladies and gentlemen? Normally, this is the question for you. How many bits we need? The opcode, we said maybe 7, 8, 9, 10, up to 1024. In Von Neumann, it was 5, up to 32. He used 21. How many bits should be available in this operand? I'm waiting for an answer. This is an operand. How many bits should be available in this operand? Come on, guys. مين معي؟ بتصير روح فتش عبد الله قدامي. Abdullah, your name is in front of me. Abdullah, can you answer this, please? How many bits I need in this? كل operand and the number of bits. How many bits I need to how many bits this operand has? Asir, you can chat. I know you like chatting. Abdullah ما جاوبتني. Do you have an answer?
No, I'm not sure, but 16.
16, okay. Yalla. Asir, you can chat. If you don't like to talk, guys, you can chat. يعني هلا Abdullah said something, it's not correct. I'm not going to say wrong, لأنه it's negative wording. It's not correct, but I'm accepting any. Tell me anything, guys. Even if it's wrong, why not? But this means that we are communicating by chatting. Oh, I have 7 chats. Okay, hello. I think I didn't upload it. Share screen. Can you guys see the screen? No. Okay, you are talking to each other. Great. So can you chat with me or talk to me? How many bits? No. This is supposed to be an easy answer from what we have talked about. I can see all participants. Let me see all participants. Betty, can you answer this through a chat? Okay, Fazan Abdullah changed his mind to 4, and this is the correct answer, so I'm gonna stop asking the question. So guys, this is a register number. How many registers we said we put in sys computers? Since we have 16 registers, then to get to any register, we need 4 bits. 0000 for register 1, 0001 for register 2, and then so on. 16 registers. So 4 bits. Here we are saying that, now I go back here. No, here. What does that mean? Large address space 2 to the power n. What does that mean? Now I need you to chat or talk to me, please. The question was for Betty at the end, so I ask Betty first. Let me see the chats. One chat went out. Okay. So the Zoom is lagging me out. And suddenly, sorry, because, okay, no problem, my friend. You can chat with me and you can answer the question now, verbally. 2 to the power n, what does that mean? Large address space in this kind of addressing mode. Large address space. What does that mean? What do we usually refer to address space? Address space is memory. And this is the memory. And they are saying here that with 4 bits, you can access up to power n. N is the number of bits in this register. So if I annotate, if this register is 32 bits, 32 bit, this one is okay. 32 bits register. Then here, this is an address to the RAM. I don't know what, did I click here? Wallahi, I don't know, I made this. Okay, so here, 32 bit. 4 bits here, 1, 2, 3, 4 bits, led me to a register that has 32 bits. This will take me to 2 to power 32-bit addresses in the RAM. This is what we mean by large address space. 2 to the n, 2 to power 32 is 4 giga, I think. So we are going to 4 giga. If we wanted to put here the 4 giga, guys, how many bits I needed for operand? I need 32 bits. So what did I do? I mean the instruction set addressing mode. It substituted a 32-bit with 4 bits, but with one extra step. If we have immediate address here, immediate address, then we don't have to go and reference a register, then reference the memory. We go directly from this 32 into here. In the case of register, we are saving space in the instruction format, yet we need one more access, one more to the register, and then on to the memory. And this is it, guys. I hope you understand. But now, let me close the chat and continue. Let me stop this. Where are you? Later. No, let me just close it. And it's here. So now we go down. Displacement addressing. I think this is where we stopped last time. In displacement addressing. Address field. Effective address. Guys, this is not the value in all what has passed before. This is not the value. This is the effective address where I will get the value from. This is the effective address. So this one saying it's an address plus content of register. It used to be A alone, or the content of A, or R alone, or content of R. Now what do? We have an address and you add to it the content of a register. So A is a base value, R register the whole displacement, R is a register. It doesn't have here memory location, it has a number. Displacement from A or vice versa, we will see it here, and this is the case, guys. So this instruction, we have an opcode, we have a register, 4 bits, we have an address A, guys. This address A is not, it can be a number. So you take this register and there is here a number and you add a number here to it, and this will lead you to the effective address. So don't forget, guys, the adding of this and this, let me annotate, this will lead to effective address And then we go to the memory at this effective address to get the operand. So what's new now? We have both of them. We have the register content. The register content, this is A. And the address, come in. This is the content of this field. This is simple plus, and effective address come out, and the memory at this effective address. Okay. What is this good for, guys? What is this good for? This is good for arrays. When you say, for example, A, which is an array, مش هيك? A is an array. So this is the memory, صح ولا لا? And the elements of the array will sit in memory location one after another. مظبوط? So this is A of 0, this is A of 1, this is A of 2, A of 3, and so on and so forth. This is how they look into the memory. So in this case, what is the base address? What is the base address, guys? Here, if I stop this, if I'm not clicked here, here. So what is the base address? Is the A, صح? So this is the A. So what is this, guys? When we write our programs in high-level language or any, each variable will have a starting address. So there is a table here. Let me come in. There is a table of content. So n is a variable, integer n, and this is its address, not value, its address in memory. And m, address in memory, and so in memory. And so is the array. This one has an address in array. Suppose 5,320. I don't know, 320. Okay, so this is the address of the array. Now I'm saying مثلا print A, print A of 5. Then what does that mean? This I can do in Java, in Python, in any language I want. Print A of 5. Then what does that mean? It will look for the starting address, حطه هون, and then it will put the 5 here, and then it will add them. This becomes 5,325. It goes to 5,325, and it reads the value in one of the register and continue. Are you okay, guys? حدا هيك wave hand. هلا كان احمد عم يعطيني وجه عابس. احمد, give me a thumb for please. For example, بدل وجه عابس, give me a thumb. No? Okay. You want me to repeat? I don't have any feedback. Okay, thank you. محيو, thank you. Thank you محي الدين. احمد ما بعرف اذا بعده معنا او بعده غضبان. I don't know. Angry. So we continue, guys. لانه no feedback. You should have said continue or sorry, continue. You can be silent, but you can say repeat. I will repeat. So I continue. What's coming, guys, is similar to this, which is relative address. Relative address. It's the same. This is the address given. هي ذاتها وين هون؟ مش رسمين الرسمي. It's the same as before, but we don't have where were we? A plus here, هون. We don't need this one, guys. So for this, next one, مش هون. I don't want to confuse you when you listen to the recording. So, oh my God. Okay, this is the displacement. Now, where are we? In the relative. The PC. I'm not going to go up and down. Then it's confusing me more than it's confusing you. This PC now is the register, guys. ما هو PC is a register. But this is not a register where you have to store anything in it because it's already stored. Can you tell me where this could be useful? لأنه you take an address, you add to it the content of PC, and you make it the effective address. What is this good for, guys?
Looping over an array.
Yes, you give a jump in general. Thank you, Mark. Yes, you are right. But in general, it's jumping. The 4 is a jump, by the way. If you know in programming language, the 4, once you translate it into instruction set, it's not actually a 4, it's a jump. So yes, so you are going through your program. And وين هيدا القلم? Okay, you are going through your program. So you know you are at this PC. صح ولا لا? You are at this PC. PC is stored already. And it happens to be jump. A jump jump to a label, guys. Labels are also numbers like here. Labels are also numbers. So suppose this is jump to 75, which is a label. It could be here or it could be there, guys. So now PC plus 75, it will take you to this. PC minus 75, it will take you to a previous one. And this will be used for the for statement back. A simple goto can take you down. A for or a while can take you up and something like that. Any questions on that? Okay, no questions on that. So we keep going. I stop this and I go down. I stop this and I go down. Base register, displacement, pointer to base, are maybe explicit or implicit, segment registers, index addressing, combination of this and that, guys. Addressing, these don't have examples. So what I did is I went and I prepared a small document. I was not able to post it, and I finished it a minute ago. So this one. Oh, not this one. Where is the document? ما اللي ضيعتها. Let me see. Where is the document? Not meeting instruction form A. Can you see this on my screen now? Or do I share my screen again? Guys, I need an answer.
We
Able to
can still see it.
1, 2, 3, 4, post index, pre-index, auto. Do you see it?
we can see them, yes.
Okay, great. So let me clear this screen لأنه هو المعاد بدنا إياهم. I'm talking about those بس with with the drawing لأنه بيقول لك can you draw and I draw it. So let's stop this now on clear أول and then stop this and then go through this. Effective address equal content of A plus content of R. Content of A plus content of R. We know this. This is very easy, guys. So it was one address and content of R. Now A and R. How many access do I have to go into memory before I complete this? I have to fetch the A. Now in the R, I fetch the register content. So this is memory access, guys. And then I have the add the two numbers, and this will be the effective address, and go one more time to fetch the address from that effective address. So I'm using this way of looking at it. طيب. So this is important, what happens first and what happens next. We might have to take a numerical example. We have been doing that, guys. 5320 وصارت 5325. It's the same here. I can draw any memory. And I put an address there and I say in register, I have this number and I'm referencing this effective address and I say load مثلا this, and you should be able to get the right answer out of it. Pre-index, it means add A plus R first and then take the memory address at that and use it. So, and the steps for that are A is updated first. So A is equal A plus R. You can use any other value, guys. You can say مثلا B equal A plus R. لأنه here you can say B equal A plus R and the effective address is in B. We don't care. But this is how they do it. يعني this looks like A equal A plus R, guys. A equal A plus R. Here it is. And then the effective address will be this new A. The new A is the effective address. So memory of effective address. And here we go. Something like this would be useful, guys. So plus R, A is updated as what? As a figure, guys. So here, A is equal to A plus R, and then A is updated, then the effective address of A, who M of EA, and there will be here a number. That is the number that's stored in the register to continue it. When I finish, I'm going to do a numerical example for all of them in order to exactly know, like what I do in my exam. I give you such a problem. Let's continue with these two and finalize this and finish with it. Auto increment, post increment, and pre increment, guys. Both auto increment, post increment, and pre increment. Plus plus A and minus and A plus plus, guys. A minus 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 A. Okay, here we go. Effective address is A. Like we did before, guys. A will be A equal A plus D. So effective address equal to A. Access A. You see these parentheses always memory location at A. So memory at EA. Where do you place that? In A. Then you add the new value with the D. واللي هي the increment. Whatever the increment is, this can be an integer, guys. Any integer, I mean. And the new A will be the content of memory A plus this displacement, plus this D, whatever it is, value. So A is the effective address. Memory of EA will be put in A here, and then A will be equal A plus B. Okay. Auto decrement, almost the same, but instead of plus, what do we have? We have the minus here. Pick up one of these, 1, 2, 3, 4, and let's do a numerical example for it. You pick one. 1, 2, 3, 4. And then we take a numerical example, and you should be able to do the numerical example for the rest. Come on, guys. Somebody pick a number. 1, 2, 3, 4. هيك غمض عيونك قل لي a number between 1, 2, 3, 4. حدا عم يعمل chatting? No. ولا chat ولا شيء. ما حدا بده ولا chat. Oh, okay, we have 3 chats. Let me see. Which number 3? Number 2. Okay, 2 و 3. فإذا they are the same, guys. لأنه 2 و 3 are the same. ليه؟ لأنه بس we change the sign. No. Oh, sorry, فكرت 3 و 4 are the same. So let's do 2, and if we want, we do 3 also. So let's annotate. You know what? Let me, which is easier to, but I need to draw. Annotate. God help me with the writing. Now we have to figure out a RAM. صح ولا لا؟ لأنه دايما effective address come from RAM. So this is RAM. We will decide on which addresses we want. We are doing 2, guys. Now we are doing 2. What does the instruction look like? The instruction said load. This is anything but load, بس معلش معمولة يعني انتوا figure it out. Oh, okay. Load. I need an effective address. Let's say 15 or 10 حتى من 10. طبعا this is not correct, guys. 10 is operating system in RAM, but it's just an example. 10 and register show, register 2. All this in binary. 11101111. 10 is like 10, 8, and 2, and the rest are zeros. And 2 is 10 and this can be all represented in this. Okay. loaded where بعد طول بالك بعد في شيء عندي طول بالك. Let me add this guys and let me put here 11 or 100 يلا. طيب. We are fixing everything now. I must have a number in 10. 10. I must have a number in 10. Okay, 10. I must have a register. They are set of register مش هيك؟ And this is the register 2 supposedly, and it has in it 5. Now things should start making sense, guys. If I have here 17, I'm gonna reference a memory location now. Which memory location I'm gonna reference? Who is going to tell me, please? شو راح اكتب هون؟ يلا. There is only one possibility of one memory access location. What is it? Which memory address I'm going to reference in order to satisfy this operation, given that it's of this format? You want to chat with me? No one? No chats. Yalla. I'm waiting for an answer. Jimmy, say something just to feel that I am alive. I'm not dead. I'm not talking to myself. Okay. The content of A. The content of A. A being a memory address. Memory address is 10. What's in it? It is 17. احنا عم نحكيهم مش هيك؟ 17. Plus what's in R? R2, there is 5. So those two give me the effective address. Now EA is what? 22. So the number that I was looking for here, guys, is 22. لأنه this effective address now here. Memory of effective address. Memory of effective address. So this will go to the 22. Pick up the number. Suppose this is minus 1. What will it do with it? Store it. It loads it. The effective address is loaded here. But what I'm doing, this is the effective address 22. What I'm doing, wait a minute. I'm storing. عفوا. This is wrong. So I'm storing to make things right. I'm storing whatever in this address in 100. So now the RAM will go to 100 here. 100 and store what? minus 1 اللي هو موجود ب 22. Please raise a finger, say something. This is a numerical example. It's straightforward. Memory address A plus memory address R, the content of R will give me an effective address. I go to this effective address. I get a number. What do I want to do with that number? It depends on the opcode. The opcode said store it in 100. It could be added, guys. It could be subtracted from 100. It could be anything. I am most interested in the effective address. And I got the effective address. I got the number in it. And I load it in 100. So here, minus 1 will be in 1. Okay. Nothing. Okay. You want to do 3 now? Let's do 3. Effective address equal A plus D. We start always from the instruction. So suppose this is the instruction, guys. I'm not gonna say what is it before. لأنه before I said load and I ended up with store to make something to make هلا حتى هيدي اللود guys مزبوطة. شو كان بصير الجواب؟ اسمع. Then I don't need this one. I'm happy that I'm on record لأنه you see the changes that I'm making to things that I'm doing. Suppose this was not there, guys, and I have this only as load, not as store. Then what do? I take the -1 and put it in AC. لأنه loading whatever in this address. Okay? Most important here, we were just resolving the effective address. But what do we do with the number within the effective address? Decides on by the opcode. So here I'm going to leave the opcode for a minute. And then finally, I make sense out of it and I say what it is. So what do we have here? We have an A. A is a number, memory address. Let's say 10 again. And this displacement, suppose is the same, guys, 2. Yalla, same question. But now we are talking about this instruction, not this instruction. How would the CPU or the logic circuit of the CPU differentiate whether it's this or they look the same, guys? Look, they look the same. There is supposed to be something in the opcode that will say, this is the 10 as a memory address, and this is the register as memory address, and this in this opcode, which is supposed to be different, maybe in one character it's different. One character will make it different, and they are different opcodes. And in here, this yes is a memory, but this one is a D. It's not a register. So this is the D. مع انه نفس الارقام ليك نفس الارقام. They will be considered as memory address and D as a number, and here they will be considered as a memory address and a register address, a register number. ما في register address هو register number. طيب. So now what happens? The effective address in 10, so this will bring the 17 in, and then this 2 plus 2. Now, I'm going to make here a memory address, guys. Who's going to tell me what this memory address is? Come on, please say something, guys. It's the same question I asked it a minute ago. في حدا عم يعمل chat? No chat, no talk. Come on, guys. Levon, say something, please. Levon, say something or chat something. A minute ago, I did the same. When I get this address, it's the effective address. So, whatever I'm referencing from memory is supposed to be at this address. To make this a good numeric example, I have to put something here, guys. So, address 19 should have something that I'm getting to. And suppose this is -5, ya akhi. I don't know what it is. Any number. Shoot. Let me scratch it. And right here, minus, let me choose something that's easy, guys. 4 is easy, I believe. -4. It's inside. So now, guys, what do you want to do with this -4? What do you want to do with this -4?
We access it.
Yeah, it is there. I have it. What do I want to do? Do I want to put it in the AC? Do I want to update? Do I load it? What do I do with it? I don't do anything with it. For example, load. What this load will do, guys? What this load will do? We'll take it to the AC. Now it's taking -4 to the AC before it took -1 to the AC. So my job here and here actually is to get the effective address. Are you okay? In here, the effective address is 19. Here, the phone effective address is for this is 22. And here, effective address is EA, effective address is 19. And then whatever I want to do with this, I can say add. Guys, if I say add here, but they load, what does that mean? Take the -4 and add it to whatever in AC. You remember the add operation? This is similar to von Neumann, but von Neumann ما كان عنده addressing modes and so. Okay, we did 2 examples, numerical examples. I hope you repeat this recording 10 times until you get every word I said, and prepare another numerical example for all of them, and make sure you understand what's happening. Okay, this document I will post to Moodle, inshallah, as soon as I finish. And now, where am I? I stopped this. I am in the Word document. How do I now go down to close this Word document? The Word document. Oh, let me stop sharing and then go to these screens that I have. Wait a minute, guys. I'm just getting rid of some of the screens that I have. Word, let me close the Word document. This one I closed. Don't save. You don't know what's happening, but I'm just closing some of my documents, guys. And this I close. Then let me share my screen again. And then look for this again. Oh, what happened to the... okay, come in. I must have closed. Let me see what's in here. What is this? What is this? What is this? Yeah. Okay, no, not this one. I don't want this one. I want this one. Come on. I want the download. I want chapter 11 again. We're in chapter 11, right? Or chapter 12. I don't. Let me see. Chapter 11. Yeah, we're in chapter 11. So now if I scroll down, all this, في عندنا instruction length, guys. Instruction, 16-bit instruction, 32. We refer to them as word also, guys. When we 16-bit instruction, a word, the relation between word and instruction is very important. So they should be one-to-one. And if a word is a 32-bit word, then you should have a 32-bit instruction. But instruction length, guys, can be variable and fixed. We will see that. Allocation of bits. Let me see. Okay. Allocation of bits. Which is better? By the way, I went through all these when I was talking about the addressing modes one way or another. So number of addressing modes you have to decide on. You might choose 3 or 4 of them. In literature, what we have seen is available in books. But مثلا Pentium can create one of its own ARM, which is a power computer. I'm going to give you an assignment on that in a minute. Command is has its own maybe addressing modes. So how many addressing modes? Number of operands. As I told you, if you go back to the recordings, VAX 11780, it used 6 or 7 operands, guys. Imagine. We don't see this a lot in current architecture, guys. Register versus memory. They both have advantages and disadvantages. If you use a register as an operand, you take less space. مظبوط ولا لا؟ قلنا 4 bits can reference 16 registers, and you can put in a register a constant, or you can put in it an address memory address that can take you to the power n addresses. Okay. Versus memory. If I put the memory location directly in the instruction, then what? then I will save one access to the register. And there is a debate there, whether this or that. Now, remind me, guys, for this, CISC and RISC. Say a sentence about CISC and RISC concerning these guys. Register versus memory. Say something about CISC computers and RISC computers when we are talking about register access in the instruction versus memory operand in the instruction. Okay. I have a chat. Let me see. How many operands? How many operands of what, my friend? How many operands of what? I don't know. Okay. I don't have an answer for this one. No, maybe another question was from previous chat. Okay, guys. RISC computers favor registers. They say, I will store everything in a register, but then the register in the CPU, it's not indirect register. So the operand in the instruction, why I'm not annotating? Here it is, guys. So this is the register number. Remember here, I can reference. This is the register number. And this is the memory location, guys. Obviously, this needs lots of extra bits. شو memory 4 bits شو memory بتوصل ل 8 ل 16 ل 15 0 to 15 هون 4 bits 1 2 3 4 bits you can reach 14 registers. Listen to me. If you are using, this is the CPU and this is the set of register in the CPU. If we are using RISC, more registers. If we are using RISC, then this is a register number that's found inside the CPU. We directly access it. We don't go to the memory. Okay. RISC rely on that. But in CISC also we rely on some registers here. Direct address here. Mission direct address register, the indirect address. No. But the number of register matter a lot. In CISC they put مثلا 1 2 3 4 register that user visible. ما هن 16 register in CISC they are not all visible to the user. لانه مثلا البي سي انت شو خصك فيه؟ you cannot touch on the PC, you cannot touch on MAR, you cannot touch on MBR. These are part of the 16. Some of them are used for a special purpose and something like this. So less and less registers in the CPU are available for the CISC. When you increase the number of registers in RISC, it means that every time you load a memory location into the register, it means it's available to us. So every time you do add or subtract or multiply on any of these memory locations that are stored in the register already, you don't have to go to memory anymore. In CISC, they say, no, let me go to memory and let me not have that many registers in the CPU and let me have complex instruction set. لأنه RISC goes with simple instruction set. This is repeated from previous lecture, but anyway, it's a choice, registers versus memory. And remember, when we say registers, you have to take into consideration register as direct inside the CPU, and this is the ultimate speed, guys. Even more faster than the cache reference in the CPU. If this is the cache, then in the cache you have to search, even though it's an associative memory, but you have to search for that location and get the number. In here you don't, لأنه it's a register number, you directly go to it randomly and pick it up and use it. Fastest. Now, if this register is indirect, then we have a small problem here, which means that you have to go to the content of the register, and then this will point you to what you want, and then this will be a more of a difficult comparison. So, register versus memory. Here we go. Memory takes lots of space. Register takes less space. Yet, register if it's direct something, and if it's indirect something else. Number of register set. I just mentioned 16 usually in CISC, 32 for each process usually in RISC, and so. Address range, هيدا 2 to power n وغيره. Address range. What kind of RAM do we have? If we have a memory of only like 1 human, of 10 guys, of 1000, عفوا. This is very easy. I can go to memory very easily. لأنه no indirect memory, directly go to memory. One memory access وخلصنا. مش one memory will take me to memory, will take me to memory. You remember those three? These are 3 memory accesses to get to what we want. And address granularity. It goes with the how we are using the address of the RAMs in the RAM. I don't ask usually question on this, so it's enough to go through it and move to what's next in here. And this is now very important to go through. What am I doing now? I want to stop this. First, let me clear it. Clear all drawings. And then close it. And then what? Slideshow. And then from current slide, I wanted to look in larger font. Okay. This is larger font, guys. This is one of the earliest computers, guys. And this is the instruction format for it. It's PDP-8 followed by PDP-10, 11, and so it's a series. And you know, when something starts, it looks genius. Now it looks a waste of space and time, and they needed more instructions, and so we will see something else in an assignment that you will do. Okay. This is an instruction set. Question, I will see. How many opcodes do we have there? This will be on your exam, guys. I'm gonna take the whole time left, maybe 15 minutes or so, just explaining this for you to be able to answer the question on the exam. It's not gonna be PDP-8. It could be something like PDP-8. You design your instruction set, keeping in mind what we did in PDP-8. Okay, here we go, guys. 0 to 2. Let me annotate. How many bits there are from 0 to 2? 0, 1, 2, and 3. 1, 2, 3. This is where everything starts, guys. How many instructions we can have if 3 bits are reserved for opcode? 2 to power 3 يعني 8. مش هيك؟ 2 to power 3 مثل كيف فون نيومان 2 to power 5 طلع معنا 32, use 21 out of them. نفس الشيء for opcode. And if I want to name them, then they would be 000, 001, 00, 010, and so on and so forth, and so on and so forth. طيب معقول فون نيومان يكون 21 instruction وPDP-8 اللي اجى وراه ب10 سنين او something like that would go for only 8? Of course, no, something is wrong. So we think more. 3 bits, let's start. From 000 up to what? Up to. What comes before this, guys? 101? Yes. بعدين 110, yes. From 000 to 101, how many of these do we have? 6, 7, 110, 6. لأنه بعد فيه 110 and 111. This is what's left. So these are 6. If I see 000, 001, 010, 011 up to 101, the logic circuit will treat it with this format. We'll treat it with this format. We will see now what the DL is, what the ZC, I don't care. But this is obviously 1 bit. What is it used for? I don't care. This is 1 bit. What is it used for? I don't care. Later we will care. بس يعني. وبعدين from 5 to 11, yes, they are used for displacement. So this is a number. This is a constant. Displacement is a constant. صح? Okay. So we have 6, remember guys, 6 instructions already. 6 instructions. They are in this format. What is the length of the instruction set, guys? What's the what's the length of the instruction? This is the 12-bit instruction, مش هيك? From 0 to 12. And it's fixed, يعني كلهم 0 to 12 لأنه we see other instructions that are variable length instruction. So this is 12-bit instructions, 12-bit instruction set. خلاص instruction set. مش راح اكتبها لانه بدها تروح معي وتضيع لي وقتي. طيب. Now I receive a 12 bits and I check the first 3 bits and it's none of these. Actually it's 110. Oh, so now I move to another format. مش أنا logic circuit, guys. When you go and when the logic circuit decode these 3 bits, he finds that it's none of these, so he treats it differently. Where does it jump? It jumps here, guys. And it reads the last 3 bits, 9, 10, 11. How many options I have here in opcodes? Now look, the opcode is here, not any here. This is the subcode that will lead me to the opcode of such instructions, meaning input-output instructions. Here I have 8 also, 9, 10, 11, and 2, 3 bits. يعني I have 2 to power 3, يعني I have 8. 8 instructions. ما خصهم بهول guys، ما خصهم بهولها. هيدي ما بدي اياها لانه it's misinforming us. هن كانوا 2 to 3 as a start، يعني ما بعرف كيف بدي افسر لك. Now 9 و 10 و 11 I have here option to take شو 8. All of these they go with what, guys? They will go with input output instructions. يعني عندي 8 input output instruction 110000 دغري بيعرف this is an input output instruction. This could be مثلا print يا أخي, this could be read from disk, this could be write to disk, this could be this and that. طيب فإذا 110 000 110 001 110 بيطلعوا 8. فإذا هول 8 من هول، مش هيك؟ 8 of these plus 8 of these. شو صاروا؟ 14 instructions so far, guys. بعد عنا one option واضح. When it says 111 هول الأساس, guys. هول الأساس. هول الثمانية هن الأساس. These are the first 8. هول هن 000 101 110 111. They are different. every time when I'm parsing as a decoder, I check the first three. So now I see 111. Oh, wait a minute. 111 is different than those. So I am ready to start a new set of instructions. He doesn't look at the end. He look at only this one. يلا لشوف. How many instruction here? How many added instruction when I use this 1 bit? It's 1 bit only. It's 0 or 1 only, guys. It's 0 or 1 only. هي ما في تكون غير 0 or 1. Okay. Okay. Look what's gonna happen now. 0 or 1 يعني عندي 2 instructions of this sort. 2 instructions of this sort. 2, but they are not 2 actually. Listen. If you see 1110, then look for a 1 here in all of these. What are they? They are instruction, guys. Look, all of these are instruction. This is an instruction. This is an instruction. This is an instruction. This is an instruction. This is. So when you see 1110, so I have 1, 2, 3, 4, 5, 6, 7, 8 instructions. Plus 8 instructions coming from here, this one. Now, if you see 111 followed by a 1, then it's a different set of instructions. صح ولا لا? So we go to this one. And this is how we go for that. 1, 2, 3, 4, 5, 6, 7. هيدي ما خصنا فيها. Not used. فإذا there are 7 here. إذا كل zeros, إذا كل all zeros, then he jumped to the next 1111. So these, both of them, guys, point to any one of these show of codes. And they are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 10, 10, 10, plus 10. 10 coming from where? From these two guys. How many instructions do we have? 6 plus 8 is 14. 14 plus 8, 22. So this is like 32. ما عدا السهو والخطأ. إذا نسيت تعد شيء معين, guys, then we go and count again. It is genius ideas that they were using in order to figure out within 12 bits. I have that many different instructions I want to run, and yet I have displacement of from 5 to 11, which is a large number, and I have all those commands in my instruction set. Okay. What is the time? Let me escape. ما عم بروح للescape. Let me close this and then do escape. Maybe this will do it. No, let me close this and بعدني عم بحاول أعمل escape. هلا عملت escape. Time is 11:54. We have 6 minutes, guys. Let me stop sharing. No, I don't want to stop sharing. Wait. Go back to sharing screen. I want to stop recording حتى ما stop recording, and now. Are you sure you want